Good day, this is Mr. Morales, and these are my video notes for our final lesson for this 9 weeks on the quadratic formula. So if you've been watching all the other videos, this is kind of a culmination of everything we've been doing up to this point now. So what we have is a new formula. This formula referred to as, rightfully so, the quadratic formula, right here on the left side, will give you the roots, solutions, zeros, x-intercepts, whatever you want to call them, for any quadratic equation every single time. And there's 3 basic steps to follow. The first step is to make sure that your equation is in standard form. That means all the x squares, all the x's, and your constant are all on one side, and your equation always has to equal 0 before this can be applied. Second, you have to identify your a, b, and c. Those are the coefficients of x squared, x, and finally whatever your constant is that's being added or subtracted at the end. After you substitute everything into the formula, you then just simply simplify, which is a lot easier said than done, because now you have to remember all your rules, not only for PEMDAS, but the rules for exponents and radicals and everything we've learned this 9 weeks. I apologize right now. I'm going to have to pause the video momentarily to let the bell ring, so you might hear one chime of the bell before I quickly pause it, or I may go all the way through. I really don't know. I might just hold on. So just a heads up for those of you. All right, sorry for the interruption there. That's a student I had to converse with briefly. All right, so let's go ahead and practice our method for today. So first thing we need to do is check to see if our equation is in standard form, and it is, and everything equals 0. Good. Next, we need to identify my coefficients. My a is the number of x squares, so I have 1 x squared. My b is the number of x's, positive 2. And c is my constant attached at the end, negative 63. Now I'm going to go ahead and go right into the substitution into the quadratic formula. So x equals negative b. B's a positive 2, so it'll become a negative 2, plus or minus, and I have a big long radical symbol, b squared, which is 2 squared, minus 4 times my a value, which is 1, times my c value, which is negative 63. All of that is under the radical symbol, over 2 times a, which is 1. Now the next step is to go ahead and do all the work that's under the radical symbol using my calculator. And when I do all the work under the radical symbol, I end up with an amount of 256. If you don't get that, it's mostly because you probably didn't put parentheses, separating your negative signs and whatnot. That's been the most common mistake. I don't know why my radical symbol is so long, so let me go ahead and make it a little more appropriate size. There we go. Over 2 times 1, which is 2. Now, the next step is to check to see if there's a perfect square root of 256. And I'll continue it over here. Square root of 256 ends up being the number 16. So now here's what my equation says. It's in 2 parts. I have negative 2 plus 16 cut in half, and then negative 2 minus 16 cut in half. Both of those will give me the answer. They're my 2 roots. So x equals negative 2 up to the positive plus 16 divided by 2. Negative 2 plus 16 on top is 14. Divided by 2 will give you a 7. So there's one of our roots. I'll use a colon to separate the other one. Now I'm going to do the same column again on top, but now I'll use the subtraction. Because remember, when you have square roots, you usually have a positive and negative answer. Negative 2 minus 16 more is negative 18. Divided by 2 will give you a negative 9. So our 2 solutions are x, I'm going to write it sideways, equals negative 9, comma 7. It's back notation. Those are the 2 spots where my graph, this graph, x squared plus 2x minus 63, will intersect the x-axis. Now, in this first example, it's really nice to have whole number answers like 7 and negative 9. But that's not always the case as we've learned in algebra. So for number 2, we'll continue this process again. It is in standard form. Everything is on the left side or on one side, and everything equals 0. So my coefficients are a equals 6, b equals negative 11, and c equals negative 10. All right, so I got that then. Substitute everything into my formula. X equals negative b. Now, since b is negative 11, a negative of a negative 11 turns into positive 11. Plus or minus, radical symbol, b squared, so negative 11 squared, minus 4 times a times my c value over 2 times my a value. I simplify the radical, I get 11 plus or minus the square root of 361, all of that over 12. Put a colon here. I'm going to check if 361 is a perfect square, and indeed it is. It's going to give you 19. The square root of 361 becomes 19. So now what I have is my two equations. Actually, let me fix my vinculum there, my fraction bar. It shouldn't be so wide. It should go right here. There we go. So 11 plus 19 divided by 12, and 11 minus 19 divided by 12. So I'll do the addition one first. 11 plus 19 divided by 12 if possible. 11 plus 19 gives me 30 divided by 12. 30. When I divide by 6, I get 5 halves. So 5 halves is one of my roots. Now for the second root, I'll do the subtraction version. 11 minus 19 divided by 12. 11 minus 19 is going to be negative 8 over 12, which simplifies to negative 2/3. There's my other root. So my roots are at negative 2/3 and 5 halves. Sorry, I have to write sideways. I'm a little out of room here. But if you've been with me so far, you know how these solutions and roots are written. So that shouldn't be too hard for you to figure out. Number 3, moving on. So now we don't have a standard form equation. I have 1 on the other side. So I'm going to go ahead and subtract 1 from the right and from the left. When I do that, I get negative x squared plus 2x minus 1 equals 0. Now it's a standard form, and I can go ahead and find my a, b, and c. My a is going to be negative 1 for the negative 1x squared. My b is going to be positive 2. And my c is going to be negative 1 for that constant I just moved over. There's my coefficients. Let me go ahead and begin my substitution. X equals negative b, which is negative 2, plus or minus the square root of b squared minus 4 times my a value times my c value over 2 times my a value. I'm going to go ahead and work on the radical symbol. So everything in that radical house, when I do all the work, gives me a 0. 4 minus 4, you get 0 over negative 2. Well, the square root of 0 is 0, so really all I have is negative 2 divided by negative 2, because you can't add or subtract 0, it doesn't change anything. And negative 2 divided by negative 2 is a positive 1. So for this problem, there's only one root, and it's at positive 1. This is one of those quadratics that only touches at one spot and then goes back down again. Number 4, same type of problem, only I have x's and constants on the right side. So I'll subtract the 4x, and I'll add 15 to both sides. Minus 4x, and add 15 to both sides. When I do that, the negative 2x squared has been unaffected. 3x's minus 4x's leaves me with a negative x. And then I had plus 15 tagged on at the very end over here, equals 0. Now this is all in standard form. So let's get the a, the b, and the c. My a value is going to be negative 2, because I have negative 2x squares. My b value is a negative 1 for the negative 1x. And my c value is positive 15. There's my a, b, and c. Let's get right into the substitution. X equals negative b, which gives me a positive 1 this time, over the square root of b squared minus 4 times a times c, all over 2 times my a value. When I go ahead and do all the work under the radical symbol, I get plus or minus the square root of 121 over negative 4. When I check for the square root of 121, I get another perfect square, so I get x equals 1 plus or minus the square root of 121 is 11 over negative 4. So I have 2 math problems to do. The first one, x equals 1 plus 11, which is 12, divided by negative 4. 12 divided by negative 4 is a negative 3. So there's my first answer. The second one, x equals 1 minus 11, which is negative 10, divided by negative 4. Negative 10 over negative 4. Negative over negative is a positive. 10 over 4 simplifies to 5 halves. So my 2 roots are going to be at negative 3 and 5 halves. Next two, number 5 and 6. For number 5, it's still non-standard form, so I have to go ahead and subtract that 24th on the right from the negative 1 on the left, which is minus 24. So I have 9x squares. Notice I have no x's, so I can say I have 0 x's. Negative 1 minus 24 more is negative 25 equals 0. Here's my new equation. Let's get the a, b, and the c. The a value is going to be 9. The b value is going to be 0. And the c is negative 25. When you have zeros involved, that usually makes some of your math a little easier because working with zeros mathematically kind of makes stuff go away. So let's go ahead and substitute in my numbers. X equals negative b, which is just 0, because there's no such thing as a negative 0, over the square root of b squared, so 0 squared, minus 4 times 9 times negative 25, over 2a, 2 times 9. And I simplify everything in the radical. 0, adding, subtracting goes away, so the 0 can just be dropped off. I have plus or minus remaining still. The square root of all that stuff in the house will give me a 900 over 18. And when I check for the square root of 900, I do know it's a perfect square, so I get plus or minus 30. The square root of 900 is 30 over 18. So I'm going to figure out my two values. I can say x equals positive 30 over 18, which simplifies to, let's see, I divide by 6, I get 5/3. And x also equals negative 30 over 18, which simplifies to negative 5/3. So basically, my solutions, x, are positive and negative 5/3, which you can write with one big symbol with a plus and minus in front of it. Thus negative 5/3. Number 6, 8x squared equals 10x. I must move everything to one side, so I'll just subtract the 10x from the right and bring it over to the left. So now I have 8x squares minus 10x's. I have no constants, so there's my equation. Let's get the a, the b, and the c. The a is 8, the b is negative 10, and the c is 0. And as we saw in the last problem, usually when you have zeros involved, your work becomes a little faster. X equals negative b, which can be positive 10, plus or minus square root of b squared minus 4 times a times your c value over 2 times a. When I simplify everything under the radical, I get x equals 10 plus or minus the square root of 100 over 16. The square root of 100 we're all familiar with is going to be 10 over 16. So my two answers are going to be x equals 10 plus 10 divided by 16, which is 20 over 16, which simplifies to 5/4. So there's one of my answers. The second answer for x will be 10 minus 10, which is 0 divided by 16. 0 divided by anything is always 0. There's my second answer. So my roots are 0 and 5/4. Not too bad. Now to the back. The back has some more extreme examples, but they're still manageable. I'm going to do, for the sake of this video, 7, 9, and 11, and I'm going to leave for you to do 8, 10, and 12 for extra credit or for your own practice. So number 7, x squared minus 9 equals 4x. It's non-standard form, so I'm going to have to subtract the 4x to the left side and from the right side. When I do that, I get x squared minus 4x minus 9 equals 0. There's my equation. My a is going to be the 1x squared. My b is going to be the negative 4x's. My c is going to be negative 9. Now the negatives mean I'm going to have probably some funky square roots. So let's see what I get. X equals negative b, which becomes positive 4, plus or minus the square root of b squared minus 4 times 1 times negative 9, all over 2 times a. When I go ahead and do all the radical work underneath the square root symbol, I get the square root of 52 over 2. 52 is not a perfect square. So it's going to have to be broken down. So I'll do some side work over here. Square root of 52. What's the biggest perfect square that goes into 52? After some work, I know that I can get 4, square root of 4, and 13. 13 times 4 give me 52. Square root of 4 is 2. Square root of 13 is just the square root of 13. So now, if I go back to my original color now, I guess it's that one, I'm going to have x equals 4 plus or minus 2 square roots of 13 over 2. Now, because it's kind of a funky answer, it makes our last steps a lot easier. I'm going to ignore everything that's in the radical symbol, ignore this piece for a moment, and look at my 4, the 2, and the 2. All those are divisible by 2. So I'll cut them all in half. I'll divide them by 2. 4 divided by 2 is 2, plus or minus. 2 divided by 2 is 1, so I have an invisible 1 now in front of my square root of 13, over, and on the bottom, 2 divided by 2 is 1. So instead of putting it over 1, I'll just leave it like this. So these two cancel out, and 4 divided by 2 becomes a 2. So you end up with 2 plus or minus the square root of 13. You leave it in that form because the square root of 13 can only be estimated to a decimal. And if you want an exact answer, you leave it in square root form. And that's exactly what I did for number 7. So number 8 will behave the exact same way. Moving on to our second to last example, number 9. Negative 8x squared plus 7 equals 4. Not standard form, so I need to subtract the 4 from the right and bring it over to the left. I get negative 8x squared. I have no x's, so I say plus 0x. 7 minus 4 is a positive 3 equals 0. Now let's get our a, b, and c values. A is going to be negative 8. B is going to be 0. C is 3. Zeros usually make our life easier, but we'll see. X equals negative b, so 0, plus or minus the square root of b squared, minus 4 times a times c, all over 2 times a. After I do the work in the radical, now first of all, 0 in the front doesn't change anything, so I can just ignore it. So I've got plus and minus, my radical symbol. When I do all the work underneath the house, I get 96 over negative 16. 96 is not a perfect square, so I need to go ahead and break up that square root of 96. What's the biggest perfect square that goes into 96? That would be 16. And 16 times 6 will give you 96. Square root of 16 is perfectly 4. Square root of 6 is just the square root of 6. It can't break down anymore. So, going back to the problem we were just addressing, in that case now, x is equal to plus or minus the square root of 96 is 4 square roots of 6 over negative 16. Now we go ahead and we simplify all of that. I know that 4 and negative 16 can be simplified. I can divide them both by 4. So I would then get x equals plus or minus 1 square root of 6 over, and divide negative 16 by 4, I get negative 4. So to make my life even easier, I can just say x equals plus or minus the square root of 6 divided by negative 4. And I'll leave that as my answer. Number 10 behaves very similarly too, so don't forget to simplify your radical with using the largest perfect square. And finally, number 11. It is in standard form. That's good news. So I can go ahead now and just focus on my coefficients. A is negative 3, B is 8, and C is negative 7. Substitution. X equals negative B plus or minus the square root of b squared minus 4 times a times c all over 2 times your a value. When I go ahead and work out the radical, I get negative 8 plus or minus the square root of negative 20 over negative 6. We cannot do the square root of a negative number. That's going to lead us back into complex numbers. If I had the square root of negative 20, I break it up to the square root of -1 times the square root of positive 20. Square root of -1, I remember, is I, so there's part of my answer. Now I need to break up 20. 20 is made up by the square root of 4 times the square root of 5. The square root of 4 is going to be 2. So I have 2i. Then I have the square root of 5, which just travels along to the right. So now if I rewrite the top part of my problem, x equals -8 plus or minus 2i times the square root of 5 over 6. I can almost leave it in that form, but I need to do some simplification. I'm going to ignore what's in the square root symbol for now and just work on the -8, the 2, and the 6. All three of those numbers can be divided by 2, or essentially cut in half. So half of -8 would be -4, plus or minus. 2i, leaves me, half of that would just be a singular I, with the square root of 5 coming along for the ride. Half of 6 would be 3, and that would be my entire answer, -4 plus or minus I square roots of 5 over 3. Number 12 behaves the same exact way. Best of luck on these notes and on the assignment that goes with it. Thank you guys for sticking with me.